Greetings, first video of the second semester. Hope everyone's watching. We're going to talk about sequences, okay? Let's go back one more slide. Okay, a sequence. It's a function whose domain is the set of positive integers. So we're going to have a function and we're going to plug in 0, 1, 2, 3, or 4, okay, but no negative numbers, okay? And here's an example. Here's a function, and my first term will be when n is 1, my second term when n is 2, and my third term is n is 3. Notice how I list these terms out. A sub 1, term 1 equals 1, is 1 over 1 is 1. A sub 2, my second term, is because I plugged 2 in for n, and that equals 1 over 2, 3, 1/3, okay? That's one way of listing a sequence. Another way, like this sequence b sub n, which is 1/2 to the n power, which if I plug in 1, 1/2, 1/2, if that was 2, my second term, b sub 2, 1/4, 3 to the third power, 1/8. Another way to list something, though, instead of listing out all your terms, is just putting this in these brackets. Symbolize a sequence, because a sequence is a list of things that you put in brackets. So sequence b sub n equals, again, the sequence brackets, and then parentheses 1/2 to the n power. Okay, obviously my fourth term, 1/2 to the fourth. Plug in 4 for n. My fourth term is 1/16. Okay. All right. Here's just an example. You might be asked to list the first 5 terms of a sequence. Okay. One way I want you to see to get alternating signs, positive 2, negative 1, positive 2/3, negative 1/2, plus, minus, or positive, negative, is in your formula, and you might have to come up with a formula yourself someday, is have negative 1 to the n plus 1 power. Because you notice negative 1 to an even power, like 2, 4, 6, 8, is always positive, and negative 1 to an odd power, like 3, 5, or 1, 3, 5, is going to be negative. So if you plug in 1 here and get 1 plus 1 is 2, that's negative 1 squared, which is positive. And I put 1 down here, 2 over 1 is 2, my first term is 2. So here's an example of me getting the first 5 numbers of a sequence. Let's plug in my second term, b sub 2, I plug in 2. 2 plus 1 is 3, odd, exponent, negative 1 will stay negative. Notice the negative, and 2 over 2 is 1, so I get negative 1. Now I plug in 3, b sub 3, now I have 3 plus 1 is even, positive, because it's even, and 2/3, notice, and then I plug in 4, that's 1/2, but 4 plus 1 is 5, negative 1 to odd, so I get negative 1/2, and so on. There's me listing, I end up getting 2/5. Fifth term, 5 plus 1, 6 is even, so it's positive, and 2/5. So there's the first 5 terms of a sequence that I just kind of went through, okay? All right, recursive sequences are kind of where you have to list, you kind of have to work backwards to start making your list. And here's a case where you have to, the sequence, it's actually the Fibonacci sequence, I don't know if you've heard of this, but my nth term, a sub n, is defined by the preceding 2 terms added together, a to the n minus 2 plus a to the n minus 1. So if I want the 20th term, 20 minus 2 is 18, and 20 minus 1 is 19, so the 18th and 19th term will get me the 20th term. Okay? So for me to get any term, though, I needed 2 terms, so I couldn't even start anything until I had to have at least n is greater than or equal to 3. So I needed these first 2 terms just to get the third term, and then we can start. So these first 2 terms have to be given under this circumstance. So let's just recursive, this is how we kind of work. Here's what we're given. A to the n equals, like I said, a to the n minus 2 plus a to the n minus 1. Okay? So if I want to get a sub 3, what's 3 minus 2? Is a sub 1. What's 3 minus 1 is 2 plus a sub 2. So my first term plus the second term gets me the third. So here's my first and second, 1 and 1. So 1 plus 1 equals 2, and that's my a sub 3. That's my third term. So a sub 3 equals 2. Let's get a sub 4. Okay? A sub 4 equals, so 4 minus 2, a sub 2 4 minus 1 is 3, a sub 3. So again, it's the preceding terms. You want the fourth term, it's second plus third. Well, what's my second? Is 1. My third term is 2. That equals 3. So a sub 4 equals 3. So now let's get finally, a sub 5 is going to be what? It's going to be a sub 3 plus a sub 4, which is going to be 2 plus, I'm sorry, a sub 4 is 3, and, oh, I messed up. Going fast, guys, here. Okay, start over. Okay, so a sub 4, I got already. Where am I? Okay. A sub 5 is basically what? A sub 3 plus a sub 4, okay, the preceding two. I plug in 5 minus 2 is 3, 5 minus 1 is 4. Okay, I'm with you guys, okay? So, 3 is 2, a sub 4 is 3, and I get 5, okay? So a sub 5 equals 5. And this is the Fibonacci sequence. Notice 1 and 1 is 2, 1 and 2 is 3, 2 and 3 is 5, 3 and 5 would be 8, 5 and 8 would be 13, and so on. Then that sequence is really flowers, petals, all these things have this sequence where 1, 3, 5, 8, 13, and so on. It's demonstrated in nature prevalent, or a lot, okay? Okay. Arithmetic sequences, they have a common difference. Notice just commas, it's a sequence. I've got 2, 5, 8, 11. Common difference is what? 3. Okay? The formula for the nth term. So here's my, is going to be, oh, I'm sorry, back up. Again, I'm trying to keep this video short. So basically, an arithmetic sequence is where you have a to the n, like your 20th term, equals a to the n minus 1, the preceding term plus the common difference, okay? So you have an arithmetic sequence when you've got your nth term equals the preceding term plus the common difference, okay? All right. Here's finding the nth term. We've talked about this. I've got, that's like n represents anything, the 20th, the 30th, the 50th, the 42nd term, okay? Is this arithmetic, 3, 8, 13, 18. I get a common difference of 5, 5, and 5. Notice when I start off with my first term, I don't add anything to get my first term, it's just there. So to get the second term, I've added 5 once. To get the second term, I've added it twice. To get the third term, I've added it twice. The fourth term, 3 times. So if you want the fifth term, you've only added the common difference 4 times. It's always 1 shy of the number of the term. Okay, so here's your formula. If I want to find the 502nd term, it'd be my first term plus whatever, 502 minus 1 times the common difference. Okay, you're going to add that common difference that many times to get that 502nd term, or the nth term. Okay? So notice 3, 8, 13, a to the sub n minus 1, a to the n. Okay? Alright, so your initial term plus, if you want the 20th term, n minus 1 plus d gets me the n, a to the nth term. Okay? We can sum things up too. We might want to sum all the list of those terms. We want to get a sum, all those terms. We want the 3 plus 8 plus, all those terms added together. And this is the sum of the nth term. And also we can use the sigma notation, like k to how many terms you want to sum. Okay? This is just, like, this is basically, like I said, a list of how we have these sequences. The first term, and, k to minus 1, how many terms, times the common difference, and k could be anywhere from 1 all the way up to 30, 20, whatever n is, okay? Alright? Here's the formula, basically. Take the first term plus the nth term. Let's say we want to sum the first 20 terms. So n times, in parentheses, the first term plus the nth term, all divided by 2, okay? It can be written this way, too. N over 2, same thing, okay? Notice here, again, here's my notation, summing up, the first, let's say, 15 terms, n terms. Again, n times the first term plus the nth term divided by 2. This is how it's rewritten. Notice, this nth term, remember, is a sub 1 is the first term plus, like let's say it's the 15th term. We want to sum the first 15 terms. This is how we get that 15th term. The first term plus 15 minus 1 times the common difference. That is how this is that right there. And notice I've got a sub 1 plus a sub 1, so I have two initial terms. So this is another way you might see it written. 2a sub 1 plus, I group that together, n minus 1 times d, and all still times n over 2. It's just a way of figuring it out, okay? So that's another way of writing it, because this is what you have to do to get that, okay? So basically what I've got here is, here's an example. I've got a sequence, 3, 7, 11, 15. Difference of 4, 4, 4. It's arithmetic. Okay? I want to sum up the first 20 terms. Notice I didn't use the sigma notation with the Greek letter sigma, but here's the sum of the 20 terms. It'd be n over 2 times a plus a sub 1 plus a sub n, which would be 1, it's 20. Okay? So notice 3, I'm sorry, stay up here. So, 20 over 2 times 3 plus, and here's how I got that nth term, the 20th term. I had to go find that, right? Remember our formula? 3 plus 20, a sub 1 plus n minus 1 times the common difference. So 3 plus 20 minus 1 is 19 times 4, and all that equals 3 plus 19 times 4 equals 79, I believe. Okay? So here's my 3 plus 79 times 20 divided by 2, or this will be 10. So that'll be 82. Should be 820. But basically, to sum things up, it's fairly easy. Okay? You just have to just figure out what that nth term is, which we know how to do. Okay? All right. And this is just for sequences. We'll get into series later. Okay? Let me do a chime check on my video. All right. So we're about done. It's 12 and a half minutes. One thing you can do is here's the 7th term and the 15th term, and if I want to figure out maybe the 25th term, I need to get a formula, but I need to find that first term. And one way really quick is that notice the difference between the 7th and the 15th term. That's 44 minus 20, which is 24. And notice the difference between terms. 7 and 15. 15 minus 7 is 8. 24 over 8 is 3. There's my common difference. Okay? So I know the 7th term is 20. So that a to the 7 would equal my first term, which I don't know what that is, plus 7 minus 1 times 3. Okay, well this is the formula to get the, let's say what we used maybe to get the 7th term. And I know that, we already know that it's 20, but now we can find out the first term. 7 minus 1 is 6, 6 times 3 is 18, 2 plus 18 is 20. So now I've got the first term, so now if I need to find the 25th term or 50th term, it's 2 plus n minus 1 times 3. Okay, just by getting the difference between the values and the terms, I got the common difference. I knew either one I could have used. I knew the 7th term was 20, and I solved for the first term. Okay, we'll see you guys tomorrow.